In today's video, we will be solving question number 21 of our packet full of AP problems. Question number 21 asks, if dy over dt equals ky and k is a non-zero constant, then y could be choice A, 2e to the power of ky, B, 2e to the power of kt, C, e to the power of kt plus 3, D, kty plus 5, or choice E, 1/2 ky squared plus 1/2. Now the first thing we should do to solve this problem is refer to our notes from lesson 6.2. In lesson 6.2, we learned that the rate of change of y is proportional to y. This means that dy over dt equals ky. This differential equation will serve as our starting point. We will now solve for the differential equation through separation of variables. Okay, so first we need to bring y to the side with dy by multiplying both sides by 1 over y. So let's go ahead and do that. 1 over y and 1 over y. Y crosses out from this side of the equation, and we end up getting dy over y dt equals k. We then must multiply both sides of the equation by dt. So let's go ahead and do that. Times dt times dt. And from this side of the equation, we can cross out dt. And we end up getting dy over y equals k dt. We can also write this as 1 over y dy equals k dt. After performing these steps, we must move on by finding the integral of both sides. So let's go ahead and find the integral.
Using one of the antiderivatives that we memorized, we know that 1 over y with respect to y is the natural log of the absolute value of y. And the integral of k with respect to dt, since k is a constant, we know that it's going to be k times t. Don't forget the plus c. We have to add it at the end of our new equation. Now what we want to do is we want to exponentiate both sides. So we exponentiate the natural log with the absolute value of y, and we also want to exponentiate the kt plus c. And from there, we know that e exponentiated by the natural log, we know that those two is equal to 1. So we are just left with the absolute value of y. And for the other side, we know using our exponent properties, we know that this is the same as saying e to the kt times e to the c. And from here, we know that when the number e is exponentiated by a constant, we know that when those two are exponentiated, it's going to be another constant. So we leave this as absolute value, and we can just say this as multiplying by a constant, which is c. So c times e to the kt.
So now we have absolute value of y equals ce to the kt. Now, when we get rid of the absolute value from y, we have to put plus or minus on the side with ce to the kt. So let's get rid of the absolute value and put the plus or minus. We can rewrite this as y equals plus or minus ce to the kt. C being a constant will absorb the plus or minus, and our final equation will end up as y equals ce to the kt. Looking back at our answer choices, we know that we have to find the choice that best fits our equation for y. It can't be choice A since there is a y in the exponent, so let's cross that out. It can't be choice C because it is added by a constant of 3, And in the equation we found, we're not adding by any constant, so let's cross that out. It can't be choice D because there is no exponent and it is added by a constant of plus 5. So no adding constants, and there's an absence of exponents, so not choice D. Finally, it can't be choice E because it is added by a constant of 1/2, and then again, we're not adding by any constants, so cross out choice E. Through process of elimination, we find that choice B, 2e to the kt, is our best answer choice. Through juxtaposing y equals ce to the kt and y equals 2e to the kt, we can further confirm that B is our best answer choice, because 2 is a constant, and these equations perfectly match. Hope this video helped.